as retail businesses move towards the cloud and adoption of innovative technologies. Kubernetes K8 has emerged as an effective solution for scaling up compute resources. K8 automates the process of deploying, scaling, and managing containerized applications, and ensures maximum utilization of available computing infrastructure on the cloud. Container orchestration helps manage clusters and achieve desired state management, enabling enterprises to build and deploy applications quicker and at scale. Large-scale retail and e-commerce chains need robust IT systems to manage processes and operations across stores effectively. But often unknown and unexpected production failures can prove fatal for companies. An hour's outage can cost businesses millions in losses. Organizations are reinforcing continuous load testing to launch future-proof applications with high responsiveness. Implementing a performance testing strategy for complex microservices infrastructure needs comprehensive analysis.
Thank you for being patient. Hello, everyone. A very warm welcome to all of you on behalf of Moritech. I hope you like this video. I'm Ramakrishna Sadhu, Marketing Manager for Content Strategy. And today, it's my pleasure to be your host for the webinar. In fact, we are very excited to see an overwhelming response for the webinar. I'm sure the attendees are equally excited to hear from industry's leaders. So in today's session, we'll hear from our industry experts on how the changing purchase patterns have actually led to a transformation of retail and e-commerce businesses, and the role of performance testing and performance engineering in application and development. And there's more. All attendees will actually are eligible for a 1 to 2 week performance assessment workshop organized by Moritech. And our speakers for today and the SMEs in this area are Mr. Scott Moore, Director of Customer Engineering at Tricentis, Mayuri Darabastu, Associate Director, RPA and Intelligent Quality Engineering at Moritech, and Shravanti Naga, Senior Manager, Hybrid Testing and Intelligent Quality at Moritech. Let me give you a quick intro of Moritech. Established in 2005, Moritech has actually evolved into a trusted global enterprise solutions provider. Our customer base includes several Fortune 500 companies across industries around the globe. Before we actually run into the actual presentation, a quick announcement. As part of the webinar, we'll be conducting 3 poll rounds of 2 questions each, and we would request 100% participation for these polls. And also, we'll be taking up the question and answer sessions towards the end of the session. So I would request each and every participant to post their questions in the chat window so we can take up all of those towards the end once the presentations are done. With that, and before I hand it over to the first speaker, we'll have the first poll question. Can we load it? Okay, you have 30 seconds to answer these questions. I see still a few guests are joining. This is interesting, but the session is starting. So a few more seconds before the poll ends. Please share your responses. Okay. Let's see the responses. Okay, in all, thanks for sharing, but there could be more. And now we'll move to the first speaker of the session, who is none other than Mayuri Darabastu. So Mayuri A quick intro. Mayur is an accomplished leader who is passionate about product quality and innovation. Mayuri has proven capability and demonstrated expertise in innovation and transformation. She brings more than 14 years of experience in creating next-gen solutions in digitization, process excellence, using RPA, AI/ML, and other technologies. Over to you, Mayuri.
Thank you, Ram. Hello, all. Good morning and good evening. A warm welcome to today's webinar. Thank you for taking time out and joining us today. As part of today's webinar, we will be sharing insights on the latest industry trends of performance engineering and also how to optimize performance in a containerized environment. Along with me, I'm excited to have Scott Moore from Tricentis and also my colleague Shravanti. On this note, I wanted to let you all know that Mauritech is a technology implementation partner with Tricentis. At Mauritech, we emphasize on redefining the end user experience through performance engineering solutions that leverage an intelligent and automated platform with clearly defined processes and frameworks. We deliver performance engineering and testing services across a broad spectrum of technologies, domains, and tools. So in this era of digital transformation, businesses and IT organizations are moving at a pace to roll out their launches using latest cutting edge technologies and also migrating to the newer technologies with the sole objective to ensure that they not only retain their existing customers, but also add to their base. And also obviously to be the market dominant leader. In the recent years, the market time has shortened. Thereby, the businesses and by extension apps are increasingly customer driven. In order to achieve this, there is a need for scalability and of course, high responsiveness. Application performance can be tracked considering multiple aspects, such as customer satisfaction. That is in terms of overall customer experience while browsing through a website or an app. And it could be also a business oriented wherein it deals with financials, analytics, and technical, wherein transactions per second would also be monitored. Another complementary approach is to see whether the performance is part of definition of done. That is, to assess whether a piece of work has been completely or adequately done as per the customer's or the user expectation. Having that said, now let's understand the latest trends of performance engineering in 2021. So the first trend to talk about, as we all are heading towards the digital transformation with the advent of Agile, continuous performance testing is gaining increased attention. The core idea is simple and straightforward. As a developer routinely and continuously develops new features and makes changes to an application, wouldn't it be great to validate it immediately as to what kind of impact each change would have on the overall application performance? The emphasis here is not only on adoption of shift left or shift right, but also focus on the collaborative and continuous performance assessment. And definitely the next upcoming trend or the trend that we have been observing is about the observability versus application performance monitoring. With the current industry focus on microservices based architectures running across different or distributed infrastructure, it can be complicated to process, to identify sources of problems because we are basically working within many moving parts. So increased observability helps DevOps team to navigate the complexities that come with the increased fragmentation in these distributed systems. However, while application performance complements the monitoring involving metrics, visualizations, and etc., most of you are well versed about it. And the next trend that I would definitely like to talk about is the cognitive performance, which is again AI/ML. That's a buzzword in the industry. I'm sure most of you would be relating to it. So AI-driven autonomous testing is the future of software quality assurance. I'm sure everyone would be agreeing on that. Leveraging artificial intelligence and machine learning in various aspects of quality engineering can help organizations achieve high maintainability, reliability, and also deliver accurate service with the utmost quality. So we can consider inducing these cognitive skills into aspects like data mining in order to detect the errors or in order to mine the logs for the errors, and also to identify the root cause of the problems. AI-based tools conduct performance analytics as well as ensure the security of the application as well. And the next trend is definitely the cloud native technology adoption. Cloud computing is definitely disruptive technology, which is an innovation that promises on-demand computing and also ensures that we power at scale with a lower cost as well. And of course, I can definitely say that it delivers it too. However, the complexity of the cloud-based systems make performance engineering even more necessary. The rise in use of containers with Docker and Kubernetes in production has been exponential these days. According to the CNCF survey, at least 41% of the respondents are using serverless technologies. Of those who are using serverless, 80% are using hosted platforms versus 20% use installable software. Now, that stats talked about themselves, right? I do not even have to stress on it. However, my colleague Shravanti and our guest speaker Scott Moore would be sharing more insights as we deep dive through this session as to how to avail high performance and availability in the containerized environments. Another trending aspect that I would like to talk about is chaos engineering, or it is most commonly known as resilience testing. Resilience testing is now become popular under another name, which is called as chaos engineering, which involves intentional introduction of a failure into a software system to measure the system's ability to tackle with it and evaluate the impact of the failure on overall system's availability and durability. In the world of software engineering, wherein we actively work on the distributed softwares, which are changing the dynamics every passing second, the fundamental problem with the distributed system is that when all the individual systems are functioning correctly, the interaction among them is something that we need to focus on, which can result in an unpredictable outcome sometimes. And also considering the COVID-19 pandemic, which has affected almost every sector, retail is one of few sectors that is under further increasing demand for services and innovation. With the rise in the digitization and mobilization being a norm, retail world is under a constant transformation, both digitally and at a business level, with changing market trends, never-ending growth, and also growth in their user base and the market globalization. Couple of years ago, 8 seconds being a norm for a page to be rendered has now been reduced to less than 1 second. Almost all the launches going app way, the response time is expected to be, of course, milliseconds. Today's retail chains have followed their customers and have been forced to operate out of online avenues. The future of mobile technologies has enabled the digitized platforms to enhance their IT infrastructure multifold. This has definitely led to an increased demand of effective quality assurance and engineering, and definitely at a matured level and also across various phases of the SDLC. With online shopping, the factor of convenience has definitely grown remarkably, and considering the global customers, there is a demand for 24/7 uptime of the digital portal. So I'm sure everybody who's using the apps can definitely relate to this. So there is a need for continuous testing, considering the constant evolution of retail software, like options like voice ordering, AR/VR adoption, tryout, real-time pricing, and also considering customer experience to be utmost priority. Retail is definitely on a constant pressure, whether to perform or to perish. And also with holiday season around, the users are more than excited to shop online, be it a Black Friday, Cyber Monday, or a traditional Christmas shopping. Customers will be out there expecting you to hold the major sales and new arrivals. So it is definitely on part of the performance engineers as well as the retail domain experts to understand the significance of performance in the overall application stability and quality. And I would take a pause here and have my other speakers, Shravanti and Scott, talk more about it and take you deep dive into the technical sessions of it. Over to you, Ram, and thanks everyone for the patient listening.
Thank you so much, Mayuri, for sharing those perspectives on how the landscape has changed for both retail and e-commerce companies. And perform or perish, yeah, It is more realistic than ever. So with that, before I hand it over to the next speaker, can we go for the second poll? There you go. The second poll is there. I would request all the participants to share their responses. There are a lot of insights that Mayuri has shared, and we'll be hearing a lot from both Scott and Shravanti. Okay, a few more seconds. Okay, let's see how the responses are. Oh, this has been much better than the first poll, so that is definitely interesting. So with that, let me move to the next speaker, our guest speaker for the day, Scott Moore, Director Customer Engineering at Tricentis. A quick bio of Scott. Scott comes with about 3 decades of IT experience across various platforms and technologies. He's an active speaker, writer, influencer, and actually the host of an online show called The Performance Tour. At Tricentis, he helps customers address their complex issues concerning performance testing and engineering, digital experience, application performance monitoring, and observability. Over to you, Scott.
Hi, and thanks Maritech for putting this on, and thanks everybody for attending this webinar. This is great. So yeah, I mean, we've already heard some great stuff, but one of the things that we know is that there is a performance cost, and whether that is in how good your performance is and be rewarded, or how poor your performance is, how that's going to impact you, especially in the retail and e-commerce world. So these are just some sample things that I've been looking at over the years. There's many studies that have been done, and one interesting statistic that I always come back to is, we know if you're in a situation where you've got a shopping cart in e-commerce, every second that you can take off of that shopping cart buying experience, you're going to be adding anywhere from 7 to 10% more conversions. And I'm sure there's somebody in your company, maybe the CFO, who could tell you that if you get that many more conversions, it equals a certain amount of money. I've got one example on here that was actually not retail, but the Miami-Dade school system was down for the first few days of their online learning program, simply because a student decided to do what I consider to be a stress test, a denial of service attack. And it was a credit card swipe, believe it or not. And it took the school system down for several days. And that was on the school's part, not having a readiness. So there was a performance cost. Nobody could get in, nobody could learn. It's a different kind of impact and a different kind of problem, other than just retail with a financial impact, but nevertheless, a huge impact. So next slide, please. We know that it has a cost. But what exactly, when we talk about performance engineering, and we've heard the term continuous already, what does that really mean? So we've got this wheel on the right here, where everywhere in your software development lifecycle, performance engineering should play a part. And that includes even before a line of code is ever even written. Or if you're dealing with third-party or SaaS organizations, when business decisions are being made, when contracts are being signed, anywhere where there might be a functionality question, there should be a performance question being asked. And that goes all the way through development, testing, monitoring in production, anywhere. But some people would say, well, I'm checking that my code is performing well, or we're testing our APIs. We have a CI pipeline. Aren't we doing performance engineering? Well, it does include those things, but that's not all performance engineering is. Or, hey, we've got self-directed teams that are doing performance testing. We're trying to shift left. Or maybe we're checking our Google Lighthouse scores to make sure that our numbers are good. Well, that's also part of it as well, but that's not everywhere that performance engineering plays a part. If you're only focused on the code or one area, you may not be thinking about the other areas, the infrastructure pieces, that the right-hand side of your pipeline. And ultimately, it comes down to the end user experience. What are they actually experiencing? We can say that the code is fast. The database people can say our database queries are fast. The network people can say we've got enough bandwidth. But at the end of the day, if the end user is still experiencing that wheel, that rotating wheel, or that spinning hourglass, there's still going to be a bad experience involved there. And that's what we want to avoid. If we think in terms of the end user experience first, and we move it backwards to all of the technology and the stuff that we as IT professionals enjoy working with, then I think that's the way we should think about it. And that's where you win with performance. Next slide. So people ask me all the time, because I'm now on the phone with a lot of customers, hey, we're trying to shift left. We're moving to DevOps. We're on a journey, but how do we know that we're doing it right? And what are some of the common characteristics that companies who are getting it and are doing it right and who are avoiding the Black Friday events where their site is going down? How do we do things like that to know that we're doing it right? And these are 4 characteristics that I've kind of come to conclude that they have in common. The first one is the idea of continuous. We've known for several years that just testing at the end of a life cycle and trying to test performance into an application, it doesn't work. And that's the reason for all the shift left terminology out there. But really what it's about is feedback early and often. So the earlier you can get feedback to know when something is performing poor, the earlier you can fix that issue and the cheaper it is to fix. So companies who do performance right, they are thinking continuous from the time code is checked in for a single feature to where it's integrated together with multiple features still in development, till the time it moves into quality assurance functional testing, to staging environment, to production and monitoring. They actually think about that as one continuous feedback loop, if you will. And that means we're providing continuous value at the same time. We're also moving into an area where you have to think dynamically. And we'll talk a little bit more about this in a couple of slides, but all of the applications that we're working with now are being deployed on dynamic infrastructure. And there are changes being made so much more rapidly than they were in the past, where you move from one app version to another. The integration has to be fluid, and the approach that we take to performance testing needs to apply that same dynamic strategy and that approach. So companies who understand that and do that, they're the ones that are doing it well, and they're winning. Priority, they're keeping performance testing as a first-class citizen. Something I've been kind of talking about frequently online on my social posting is the concept of not using the term non-functional requirement. I think that term has to go. We have to use a different term. At Tricentis, we use the term operational requirement, because think about it. If we say something is a functional requirement and then everything is a non-functional requirement, when was the last time you thought about defining something by what it's not? What if I said, hey, dog, you're a non-human? That doesn't make a lot of sense. So if something performs well for one, but it doesn't perform well for many, is it really functional? Is it really operational? Is it really ready for production rollout? I would say no. So I'm going to use the term operational requirement, and that brings it up to being equivalent to non-functional, not functional, not subservient to it. And as we got to have an honest conversation about performance. Performance is a niche skill set sometimes. There are certain things you have to know and think differently than you would if you were just a functional engineer, or sometimes if you're just a developer, you have to think in terms of what an operational person would think about: servers, hardware, BIOS, protocols. So there are some niche skill sets involved, and I think you need that and some level of specialization. And not everybody's going to agree with that, but I really believe that's part of the companies that are separating themselves and doing well. That's what they have in common. Finally, the lifecycle focus. It's not just about your code. It's not just about your APIs. And it's also not just about your infrastructure, but we look across the entire life cycle from beginning to end. We observe, we don't just rely on traditional APM and get a couple of timings here and there or some synthetic monitoring. We're actually looking at everything about the app, and we're able to get down to the needle in the haystack to pull out what's wrong and how can we fix it? How can we make it better performing? So those are the areas that you should be thinking about in your company to make things better. So as we move on to the next slide, we can see from years past, going from left to right, this is the way we used to roll out applications on bare metal, and it's still being done to some extent. Then along comes the early 2000s, a virtualized environment, VMware, and virtualized machines. And that changed the way that we roll it out. And then the cloud kind of took that to another level. But as we've moved into more modern applications now over the last few years, now we're deploying to containerized applications. And think about this, some of the containers that are running right now for a production system may not even exist an hour from now, but we still need to observe the performance of what they're doing now. Each hop, we're going to need some tracing involved on that. And we've got to be able to dynamically monitor that when those new pods and nodes are created and when they're scaled down, because we have auto scaling now. So we got to think about that. In the same respect, if we move to the next slide, we've got to change the way we address our testing environments too, because we know in the past we would have to create some kind of a performance testing lab, like on the left, and we would have some kind of maybe machines on-prem. Maybe those are bare metal machines. We would have some virtual machines in the cloud. Now we might even have a few containers, but right now they're all running and they're all just sitting there waiting to run a test. They may not be used all the time. So now we enter the era of dynamic infrastructure in a performance testing lab. And so that's where we're going here at Tricentis and Neoload. That's one of the big features I really love about it, is that we can actually run a test where we create the test resources that we need, the controllers and the load generators, the controller orchestrating the test, the generators generating the test for whatever load we need at the time. It builds those, runs the test. When the test is complete, the infrastructure spins down and you're only paying for when you're running a test. I think that's huge. That's the way we're deploying applications under test. That's the way we should be deploying our lab. So dynamic infrastructure is a strong point for Neoload, I think. So as we move to the next slide, we can see that our dynamic infrastructure supports all the major cloud vendors, which means I can have load generators on Amazon, Google, Microsoft. I can deploy them as Kubernetes clusters. They're all containerized, and then I can spin them now. So if you're deploying your app with a multi-cloud strategy, you can test it with a multi-cloud strategy, and then you can see the differences there as well. So this is something that we can also show in the tool a little bit later on when Shravanti presents. So in our next slide, I want to show you this. This is not every product, obviously. This is just example products that do this, but think about the observability that we've been talking about, not just traditional APM. It's made up of metrics, logs, and tracing. So for metrics, I've got Prometheus. You think about a Kubernetes deployed application. Typically, Prometheus is deployed as a node exporter with that. And then for logging, we might use something like FluentD to pull log information and send that to wherever we want to send it to. Maybe you're looking at Grafana, or you're looking at Elasticsearch and Kibana graphs. But then we've also got the area of tracing. Remember I said we have some things that won't exist an hour from now or even a few minutes from now, but we still need to be able to compare those hops. This is where open tracing it comes into play, and open telemetry as well. So you're going to be hearing a lot more of that out in the market, and we need to be able to pull that information in while we're running load test. So in Neoload, we actually have started down this path of supporting this. And in the next slide, you'll actually see we have a Prometheus monitor. So, and it's dynamic, meaning that you can set up your PromQL statements in Neoload for anything that exports data through Prometheus. And there's tons of new Prometheus exporters that are coming up all the time. So anything that supports that Prometheus exporter we support. So you can run your same PromQL that you might run for Grafana example. And as you test your application, you might have to have auto scaling turned on. At what point does a whole nother pod or another node come up? Well, we need to be able to see that that has come up and monitor that as well. So as those are created, we add those additional data points. Though it still monitors it, it doesn't lose it. And then whenever it scales back down, it stops monitoring. So you can correlate the data coming from Prometheus with the transaction times and with all the other monitors that you've built in to your load testing product, which I think is a really strong point. So I'm happy about where we're going in the way that with Tricentis in this terms of how we're deploying applications. That's how we're deploying our performance testing environment, and we're approaching it very much like we are development. And I think that's a good thing for everybody. So with that, I'm going to turn it back over to the speaker.
That was quite insightful. I'm sure many would agree that performance testing goes way beyond than just being a non-functional requirement today. With that, I believe there could be a lot of questions. Please post your questions in the chat window so we can have them addressed by the panelists towards the end of the session. Before I welcome our next speaker, we can take this third poll. And please note that this poll is only for the Zoom participants. Okay, 2 more questions, and we would request the participants to share the responses. And we will appreciate 100% participation over here. Ten more seconds. And yes. Okay. This was much better than the second poll. Thank you so much, participants, for sharing your responses. Now we'll move to the presenter of this session, Ms. Shravanti Naga. So Shravanti is a seasoned hands-on specialist in performance engineering space, and she's always focused on improving the user experience by ensuring that applications remain resilient, performant, and highly available. At Mauritech, she leads the performance testing and engineering vertical of the IQE practice. Over to you, my Shravanti. Sorry.
Thank you, Ram. So, yeah. So in continuation with the insights shared by Mayuri and Scott, let me throw some light into the deep dive technical aspects of containerization, more specifically Kubernetes, and how can we assure performance with a practical demonstration. So I'll just take an evolution of how containers have come into place. So in earlier 80s and 90s, we used to have physical servers. And we had 3-tier architecture wherein you had a web app and database servers. And it was a monolithic system with huge, everything intelligence is built only on one application server. And comparatively, they are much slower and they're very heavy. And predominantly, they used to follow waterfall model. However, when it came to 2000s and 2010s, the last decade, virtual machines wherein we had gained a lot of prevalence, and cloud also had gained a lot of prominence. So with this, it's no longer a 3-tier architecture, but it's n-tier architecture, wherein you'll have multiple third-party components in your architecture. And it's not just being controlled by your own organization also. There can be multiple interacting components which you may have to take care of, or you'll have to ensure that those performance wouldn't impact your systems. And at the same time, due to these independent silo components, microservices had gained a lot of reputation and they started becoming very popular. And due to this, microservices, individual services could be deployed and they could be deployed in your production environments much faster. And thus, agile methodologies came into place and all of that. And after this, from 2014 and beyond, along with the rise of microservices, containerized environments also had gained a lot of prevalence. So we'll look into further slides, what problems they'll address and all of those. So previous slide. So Kubernetes in a nutshell would, and as part of containers, you have Docker and Kubernetes, which gain a lot of popularity. So Docker is the base component, which is used to set up your containerized environment. And Kubernetes is the component on top of your Docker, which is used to administer and orchestrate your environments. And this is definitely much faster compared to your previous models and lightweight. Also, it could be easily integrated with your CI/CD deployments. So Kubernetes, in a nutshell, it does orchestration of your applications that are packaged and run as containers, and which is very, very helpful for these days microservice-based applications. Yeah, let's move on to the next slide, please. So if you look at how popular Kubernetes became over the last 5 years, if you see, containers itself had rose to 92% compared to 2016 to this year. So it's like 300% over the last 5 years. And especially if you take Kubernetes, it is almost 83% of applications do use Kubernetes in production. If you see development, test, production, it's quite high. The implementation of Kubernetes is really going very high year on year. And CNCF, which is actually maintaining Kubernetes now, it sees like there is a 50% increase of projects in its survey. Every year, there is a 50% of more Kubernetes implementation. So let's move on to the next slide. So what exactly constitutes your Kubernetes architecture? So essentially, you will have your master node, and there are worker nodes. There could be n number of worker nodes. And each worker node would have components called as pods. And pod is nothing but a group. It has internally containers. A group of similar applications could be put together in a container, and those pods are being grouped in one single worker node. Okay. And Docker is essential for any Kubernetes architecture. It's predominantly Docker. There could be other runtime environments as well, like CRI also. And so just a brief of the various components. Master node has got a component called control plane. And out of this, the API server is actually the API front-end layer for you to communicate with your cluster. Scheduler does the actual job of scheduling the communication between the various pods, the various tasks assigned to your pods and containers. Control manager, it's like a daemon service, which does take care of the whole health check of your clusters. HCD, it's like a data store, key value pair data store on your cluster. And kubelet, it's like a small agent which should be run on each of your nodes, so as the communication could be enabled between the nodes and the master node. Kubeproxy, it does the basic network proxy functionality, the network communication between the various components. So let's move on to the next slide. So yeah, let's understand. We have seen, okay, Kubernetes is really gaining popularity and all of that. But how is Kubernetes influencing the overall application landscape? There are definitely, the rise of popularity is due to its own benefits. Let's look at a few wherein it's easier deployments. So definitely whatever used to take hours in the past, it could be done in probably minutes these days because of Kubernetes benefits. And it's also, if you see, predominantly for retail-based applications, wherein the load is quite unpredictable, and you cannot manually add servers or increase your number of database servers at runtime. So this auto scaling and scale down based on your user loads would be really helpful. So that's the vital aspect of Kubernetes. It does auto scaling and auto scale down of your infrastructure. And it's completely fault tolerant. The lot of issues which used to happen manually in earlier deployment models are no longer there because it's completely taken care by Kubernetes intelligence. And also due to this, it's self-healing. If there are even any issues or if there is any pod which is going down, the downtime is hardly negligible. It's like you will not even see, or the users won't experience any downtime in your whole application landscape. and it's automated rollouts and rollbacks. However, having discussed about these benefits, there are certain challenges as well. Due to this dynamic auto scaling and scale down of infrastructures, it's really hard to nail down the performance issues. So as our guest Scott was saying, whatever pods which were existing prior in your, when you're running a test or when your peak load is coming into your architecture, may not be there after 1 hour. So if there are any performance issues, how do you track? Because those pods or those containers are no longer existing after an hour. So the key strategy, especially with respect to performance monitoring and engineering, you will have to deploy the right APM and observability tools. So wherein you will be able to monitor the health check of your applications, of your whole cluster continuously. We'll look into observability in detail in the next slide. So these days we are quite often hearing the word observability. Instead of earlier, it was all application performance monitoring tools. Now observability is the buzzword. So what exactly is observability? Aren't we doing it earlier? Yes, we might have been doing it, but observability is like put together all your logs, metrics, and tracing as stated by Scott, wherein you'll have continuous metrics coming in from all your different scattered tools, and you try to get a holistic picture of your whole environment. So if you say logs, it's like your web application database logs. There are metrics and your APM tools and uptime, all of those. Yeah, next slide, please. So this is just an example of one of the popular Grafana observability tool, wherein we used to just use Grafana or InfluxDB dashboards. But when it comes to observability, Grafana is coming up with a whole new stack, wherein Prometheus could be Prometheus, Cortex, InfluxDB, Thanos could be used as metrics. Logs could be your Grafana, Loki, and Splunk, Elasticsearch, Dynatrace. All these tools are becoming and evolving into observability tools, and you can trace it as well. So this is a sample Prometheus and Grafana dashboard, wherein you'll be able to get to know how is your Kubernetes cluster performance and how are the various pod utilizations look like, your CPU, memory, and all of those. Yeah, which I'll show in my demo. So as Scott was saying, this is a sample which Neoload tool is offering, wherein you would be able to configure your Prometheus metrics, and you can get your whatever stats from your Prometheus or Grafana dashboards, you'll be able to get it integrated in your Neoload tool as well. Yeah, next slide. So I'll brief you about a case study which we have done at Mauritech. So the client is a leading retailer in the United States, and they would like to migrate it from monolithic legacy application to containerized microservices. And we had to test it with 10,000 users. These were the tools. We did leverage Neoload, Dynatrace, and we did leverage Prometheus and Grafana. And we did usually load and stress tests, which usually was sufficient to help us isolate out the issues. So the key highlights are we scaled the users from 2,000. Initially, we started with 2,000 users, and iteratively we did multiple rounds of tests until 10,000 users. And we leveraged Dynatrace. Dynatrace is evolving, and obviously it has got a lot of built-in intelligence, and it's providing every day, as Scott was saying. It's a lot of new tools are coming up, and every APM tool is also evolving into observability space. So we leverage certain capabilities over there, and we leverage Grafana. And yeah, finally, the outcome was like we were able to scale from 7,000 to 10,000 users with detailed observability monitoring and iteration of tests. So next slide. So in summary, Kubernetes is here to stay, and it's bound to become the front and center of your infrastructure as a code. And definitely it's taking over the provisioning, scheduling, and managing of resources. And so with that said, like performance engineering and sizing the Kubernetes clusters in the right way would definitely help the organizations multifold. So as my colleague Mayuri was saying, these are some key critical findings of CNCF survey, 2020 survey. So definitely we could see that the serverless and Kubernetes are gaining prominence. So with that, I'll just take you through a demo. So the objective of this demo is to show this is a sample application which we had deployed on Azure Kubernetes cluster, and we had leveraged Neoload tool, and then I'll be showing you what exactly we have done. So this application, it's just a simple application. We didn't want to take a very heavy application in this demo. So it's just as you click this cat's a dog, the score would increase, and we did develop the script in Neoload. Okay. And as Scott was saying, we did configure, along with all our other metrics, we did configure Prometheus queries, wherein you can see you'll have to write these from QL, and wherein you can capture at every level. Using Prometheus, we can capture your pod level, CPU, memory, disk utilizations, container utilizations, and we had Dynatrace in place for this application. So that's a quick brief about the script. And yeah, if you can just, okay, due to the time constraint, I would like to show the read-only results, which I just did execute a while ago. So if you can see here, we can see all the client-side metrics like user load, throughput, how is the memory utilization on your load generators and all of that. Along with it, we have captured the Prometheus metrics as well. So these are some sample Prometheus dashboards, wherein if you see here, this one graph, here you can see this is during the test, and this was just before the completion of the test. So if you can see, the number of pod utilizations are quite high. The number of pods are quite high. If you can see here, there are more number of lines. And if you see the other way around, if you, yeah, here if you see, it's after the completion of test, wherein the pods did come down after your completion of the test. And this is in the Neoload tool. I would like to show you, so one second. So just a second. Yeah, so we did configure the same in Grafana. So as I said, like Prometheus is a metric collection tool, wherein you can have you can write your queries and all of that. And the Grafana is like more visually pleasing tool with all the integrated dashboards. And now that Grafana is moving more into observability with its latest features like Grafana Loki and Tempo, it has got like multiple predefined dashboards, wherein you can get to know your cluster memory, CPU utilizations, how with the pod level CPU utilizations, you can configure based on your time and all of that. These are few of the dashboards. I did configure multiple dashboards so that you can get at a detail level. And yeah, so this is about Grafana, and you will be able to see that the same in Neoload web as well. Okay, and this is your, we have used Dynatrace, so you can configure your own customized dashboards, and you will get to know which component of your cluster is taking more memory and all of that at a very detailed level. So this is just a sample. And yeah, so usually that's about the monitoring aspect of it. I would just like to show quickly what Scott was highlighting about dynamic infrastructure, wherein Neoload has recently launched its dynamic load generation, wherein your load generators itself would be part of containers. So as soon as your test gets triggered, you can configure your container cluster details. For example, I've taken here Kubernetes cluster. I did leverage AWS for this. I wanted to have a mix of multiple clouds. So for my application, I did use Azure cloud. And for this, I did want to test it with AWS. We'll have to configure your API token and all of that. And once you add your, and currently it supports OpenShift and Kubernetes, we'll be able to see those being listed here in your resources. And then when you start your test, so I'll just show quickly, we'll have to select our script. And then instead of your static new load generators, you can, it displays your Kubernetes currently configured cluster details. So with us, you can set how many clusters, if the load increases to certain limit, how many load generators it should increase periodically. So currently, if I'll say 2 nodes, so that's it. And we have to start the test. So yeah, it would take certain time. So you will be able to see, like, dynamically as you increase your load, it does add your load generators on the fly. And as soon as the test gets over, they are shut down. So that's like a great feature, which is being implemented by Tricentis Neoload. So yeah, it takes certain time. So we'll keep it on, but yeah. So it will spin up the VMs, and you can configure your size of your load generators as well. Like if you want to spin up small, medium based on the size, you can spin up your what kind of load generators would you like to use in your test. So while this gets done, we can go over to Ram. I'll be showing it also later.
Okay, thank you so much, Shravanti. And you've taken us to the evolution of containerized environments. I'm sure this session has been very insightful and interesting for the participants. A lot of knowledge and inputs that I'm sure all of us must have gained. So I see a lot of questions around. So we have come to the last segment of today's session. So with that, we'll quickly move to take these questions. So here's the first question, and Scott, I was hoping you could answer this question. So with performance testing, how would you actually benchmark good SLA for any service?
You know, one thing I always recommend to clients when they don't know how long should something take, nobody really argues with Google's culture about performance, and they've put out something called the RAIL system. So if you Google RAIL, RAIL, and each one of those letters means something, it boils down to this: any fully rendered web page should be under 5 seconds, or you should probably say red flag, there's a problem. For any specific API or microservice or something that's coming back at that lower level, it should be around 100 milliseconds. Now, some people would say, well, hold on a second, we have stuff that's longer than that and it's okay, we're fine. This is just a starting point. There are valid reasons why you might have something that takes longer than that. But then also around that, you should put what I call a performance budget together, not financially, of how expensive that page is. So if there's a fully rendered page made of so many services, so many calls, so much third-party content, JavaScript, CSS, there's only so much you can fit into a pie before the pie becomes just a hot mess. There's too much stuff to put in there. So putting together that budget and how long each of these things should take, we've got to be within 5 seconds. So how many services, how many resources does that take? You start putting that down as sort of a starting point. And if you're a person who's a practitioner and your management is asking, what should we set? Always, I bring up Google because it's a more recent example and nobody really argues with that. So that's my suggestion.
Thank you so much, Scott. The next question, Shravanti, this is probably for you. Can containerization be only used for microservices-based architectures?
Yeah, Ram. So yeah, in a nutshell, the answer is no. You can use containerization technology or environment containerized deployments to any kind of technological application you might have. But it became quite synonymous with microservices because they both gained popularity in parallel. But yeah, it is much more advantageous for microservices because you can just deploy your component of your respective microservice onto a specific container and it does its job. Whereas if you have like dependent application with huge components and all of that, it becomes little complex. Otherwise, yeah, it could be used for different technology applications.
Thank you, Shravanti. I see more questions coming in, so this is pretty interesting. So the next question, Scott, this is probably for you. So what is the value of manual testing and continuous testing when it comes to application development?
Well, if you're moving towards DevOps and you're an SRE, one of the tenets of being an SRE is you want to reduce toil, anything that's toil, meaning we want to automate everything that we can possibly automate so that we don't have to do the tedious stuff. We can do the stuff that counts. Does that mean that every single thing needs to be automated and continuous? No, there still needs to be manual checkpoints for things. There needs to be some eyes on something. If you're just building a continuous integration pipeline and testing and nobody ever looks at the reports, why are you doing it? And if you're not looking at the things you're measuring, why are you measuring it? So somebody at some point in these stages needs to go and look at this stuff and make a decision. Well, hold on a second. We've got all these reports and we got all these tests, but we're still having problems in production with performance. We're still having clients complain and they're talking about this. So what's the disconnect? If you never go back and look and think about it, maybe it's the fact that what you're automating or what you're testing doesn't match what end users are actually doing. And when you get those to match, you start finding the answers. So I had a person that I was talking to just the other day who they ran through that and they had to create an environment where there was a stopping point where they got together in a room with developers and testers and said, what are we actually seeing here? There was actually a situation where a timing was actually much better and that caused a problem. You mean something faster is bad? Yeah, because somebody in the development organization forgot to put a security check and a data check in. So of course it was faster, but faster in that sense meant worse, not better. That takes sometimes you have to have manual eyes to look at that. So that's where manual plays a valid role and gives us a lot of value, but you still have the continuous testing going on to grab some of the low-hanging fruit.
Thank you, Scott. The next question, it's about what could be the various challenges when scaling up or down the environment? Shravanti, would you like to take it up?
Sure, Ram. So as I've stated in my slide, coming from a performance engineering perspective, performance testers perspective, it's usually there are a lot of benefits with the scaling up and down. You need not have to maintain the environment from a developer's perspective. But if there are certain performance issues, how would you identify those issues? Because whatever environment wherein you had seen performance issues is no longer existing after the completion of your tests. So that's a key critical challenge. That's where observability tools are gaining a lot of prominence, wherein you need not have to wait for the completion of your whole test executions and all of that. It should happen live. It should happen on the fly. What are the various issues in your application? So yeah, observability tools would resolve few issues there. Hope I've answered that.
Thank you, Shravanti. Before we move to the next question, one thought for all those watching on YouTube, please post your questions there. We'll have them answered. The next question, Scott, what's the difference between monitoring and observability tools?
So in traditional APM monitoring, we would get sort of like maybe an end user timing from a synthetic script that would run every minute, 5 minutes, 10 minutes. And we would then compare that with things like CPU, memory, network disk, the four main things that we look for in infrastructure. We'd try to compile them together. Sometimes we would go further. We would get database queries added into that. We would get diagnostics or profiling information from either the database or say you're building a Java application, what's inside the JVM. And some of that is good. And some of that would help us find things. But now we're adding metrics from logs. So web server logs are built into there. So we've got things like Splunk and Elasticsearch that can pull that information together and correlate that together with us Dynatrace, some of our other partners, RUM, real user monitoring, where people are on a website, they're clicking a button and it's grabbing that information in real time, and putting all that stuff together is putting together sort of a real-time view of everything that's happening. We're still getting all those other metrics that we talked about, but we're adding additional metrics to see that, what I call the 360-degree view. And then you can pinpoint a section of time where maybe somebody created a support issue, or maybe somebody's complaining about something on Twitter, for example, and you can pinpoint that time, that user, that thing, to try to pull, not only determine what the haystack is that's the problem, but pull the needle out of the haystack. And I think that's really important today.
Thank you, Scott. And the next question is from the YouTube audience. So any thoughts about the front-end optimization? So Scott, Shravanti, who'd want to take it up?
I can talk a little bit to that, and Shravanti, you can too. And I was actually looking at that question. It's very important. And this is where we talked about performance budgets, where you can only fit so much into a page. And we can look at things like GT metrics and web page test for that front end information, where they'll actually guide you through saying, hey, Google Lighthouse is another tool that you can use inside of a browser tool, developer tool. And it will show you, here's where you're got a very high payload. It's too heavy. You're pulling too much down. Your images are too big. You need to compress them. You've got too many third-party JavaScript calls that are blocking your main page. And so you're waiting on Twitter or Facebook to do something before you can render your page. So that front-end optimization, extremely important today in today's applications. Shravanti, if you want to answer that as well, you can.
Yeah, Scott. So in addition to what Scott had said, I think definitely front-end plays a major role, especially with the retail applications, wherein these days, due to the online shopping, where 90% of people prefer online shopping, your images or what attracts a customer is the front end. It's not just your back end or your application performing transactional wise. It's good enough. It should be like your pages should be very attractive, and definitely they should load much faster. Hence, front end monitoring is an essential component of performance testing and engineering. So usually the practice is, when you do a load test, you measure the front end performance with a single user using any of the tools specified by Scott, and see that the front end is not degrading your overall application performance. So yes, front end is a mandate for these kind of retail based application predominantly. Yeah.
Thank you both. I know we're running out of time. So one last question, and I promise we'll definitely get the other questions answered. There are so many. So when it comes to client-side mobile apps, what, according to you, are the best tools for performance testing? Scott, Shravanti.
Shravanti, I'm going to let you answer that.
Sure, Scott. Yeah. So as I was saying, front end is equally important. But along with front end, it's not just ensuring the applications are performant on your desktop or laptop. We ourselves does most of our online shopping through mobile phones. So definitely ensuring that the mobile app is equally performant as your desktop app is equally important. And few of the common tools, which we have a lot of tools, Appium Studio, combination of Appium Studio with Load Runner, or most of the load testing tools does provide recording the mobile traffic through proxy. So we'll have to probably leverage one single user test with a real rendering tool like Appium or Aptim. There are a number of tools, but use a tool which is quite stable enough, which would work in conjunction with your load testing tool. And rest of the backend load, you could do it from your load testing tool. So that's the usual best practice.
Thank you so much, Shravanti. And I have to thank Scott, Mayuri, and Shravanti for the wonderful insights and the presentations, and also those answers. So I'm sure participants would have found this very insightful. And there are still many questions. We'll try to get them answered over the next couple of days. And if you can look at the screen, so we have the email ID provided. If you have any other questions, or if you need to reach out to us, please contact us. We have the email ID provided. And do like and follow our LinkedIn page. Stay tuned. We are very active on the social media platforms. Okay, before we sign off, as I mentioned earlier, all the attendees will actually get to have a 1 to 2 week performance assessment workshop organized by the Mauritech. So with that, we come to the end of this session. Totally appreciate the time spent, participants and speakers. Thank you so much for joining me today. And I believe you have thoroughly enjoyed the session. And we'll soon respond to your questions for the emails.